while we've seen most of these reactions before, I'm going to group them together as reduction reactions. I'm going to say that there's no mechanism required for any of these, but you do need to be aware of all of them. So the very first reduction reaction that we worked with was essentially an alkene plus hydrogen, and it was done with the aid of a nickel catalyst at 150 degrees Celsius. This produced the corresponding alkane. This process is known as hydrogenation. Okay, you need to know the catalyst is nickel, and you need to know the conditions, the temperature. The next reaction that we may have not seen in great detail is the conversion of a nitrile to an amine. This is done with the aid of lithium aluminum hydride typically, and from the nitrile produces the corresponding primary amine. Alright, next up that we would have seen would be the conversion of a carboxylic acid to the corresponding primary alcohol. Right, this requires lithium aluminum hydride again. All right, and it proceeds so vigorously, that the aldehyde, that would be the intermediate step here, can't be isolated. So when we do the reverse process there and we go from the primary alcohol up to the carboxylic acid, unless it's refluxed, you can actually capture the aldehyde there, but we can't do it backwards. All right, lithium aluminum hydride is too powerful of a reagent. A ketone can be reduced to a secondary alcohol using what's called sodium borohydride, that's NaBH4. Right? Lithium aluminum hydride can do this, but it isn't required. The reason that we'll often opt not to use it would be that it's a little bit more of a dangerous reagent, and sodium borohydride can do the job just fine and is a little bit safer. Right? The last explicit reduction reaction that you should be aware of is the conversion of nitrobenzene into the phenylamine. So this is done typically with with the aid of tin and in the presence of concentrated HCl. This produces an ammonium type ion shown there in the middle. Right, this then needs to be treated with a strong base, sodium hydroxide, to remove the additional proton and produce the corresponding amine. You can note, if you saw me have it up there on the screen and I took it back off, that water is the other product there. For the most part, we're really just interested in the major organic product because there's quite a few messy products that would come out of that reaction. Right, so I'm just going to add a note here that reagents such as zinc, for example, are reducing agents. So when we studied redox chemistry, you would have seen a reaction with some oxidized species and zinc, and you would have identified zinc metal as a reducing agent, right? That is still true for organic chemistry. Zinc doesn't have the power to reduce all organic compounds, but if you see it in a reaction, right, you should recognize that it is a reducing agent and that the reaction should proceed as written.